All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 98 is on the screen. Shouldn't take you long, and we're going to move on right after that because we have a lot to cover today. So, yeah, we're done with all the easy systems of two variables, two equations. Woo-wee. All right. All right, so copy and all right, check with the neighbors, see what they have so far. They should be just about done. All right, so for number one, you guys know the process for that one. I need a center and a radius for that one. Center and radius. Let's see, what you get for center and radius? Let's start with Annette. What you get for center and radius? 6, -5. And the radius? 3. 6, -5, 3. Hands, have you got something like that? Looks about right. And then the graph. Give me a second. Okay. Radius is 4. Double check. Is it 4, guys? Yes? All right. Not bad. Okay. Let's see. So radius 4. Thank you. All right. So with that said, I need a sum. Annette, pass someone. Abby, what'd you get for the sum? 5 plus I. Hands, have you got that? That is correct. Let's go to the difference. Pass someone, Abby, for the difference. Joseph, difference. 13. -13 plus 5i. Looks about right. Double check your work. Now we need the product. Pass someone, Joseph. Mario. -30 plus 7i. What? $35i. And you got that? Looks about right. Let me just double check because -6i squared. Then we got 27i. Then we got +8i. And then we got -36. We know this one is a -1, so that's 6 plus 35i minus 36. Oh yeah, Mario, let's go. Woo. All right, need factors for this one. 2 factors. Pass someone. Factors for number 3. What is it? X plus 2. And then? (3x plus 4). Hands, have you got something like that? All right, looks about right. All right, number 4. Our cubic function looks like this. And what's going to happen according to this transformation? Talk to the neighbor, please. What's going to happen to that? according to that. What's going to happen to that? Pass on, Gio. Enrique. 4 to the left, and then 5 down. So far, so good, but you forgot this. Flip it, yes. So the first thing we flip it, and then we move it 4 to the left, and then 5 down. So then we end up with something that looks like that. All right. Last but not least, I need a solution for the system. I'm going to go over this one just to double check to make sure we got it. So hopefully you said I'm going to eliminate the y, so that means you needed to multiply the second equation times what? Times 2. So that gives me 2x plus 4y equals to 12. So now we can combine. These cancel. We're left with 3x equals to 15. Divide by 3. X equals 5. All right. Now we need a y value. So I'm going to use, I'll use the top one. We got x minus 4, y equals 3. Instead of x, I'm going to substitute there the 5. Minus 4y equals 3. Minus 5 minus 5. Negative 4y equals negative 2. Divide by negative 4. Divide by negative 4. Y equals 1/2. Is that correct? Hands if you got something like that? Yes? 5 minus. Yeah, looks about right. All right. Copy the agenda, please. Warm-up number 98, system of equations in 3 dimensions. Ooh-wee. Let's go. We have arrived. Let's go. Enough of those puny little 2-variable, 2-equation systems. Let's go. Right? Am I right? Am I right? Huh, Mario? That's why today you're only having 3 problems. All right? Once again, warm-up 98 is done. System of equations in 3 dimensions. And hopefully for tonight is 3D play sheet, 3 problems only. Here's the code for access to the home plate. MYBA8. MYBA8. Now, yesterday you had home plate were numbers 1 through 12, but only the odds. Is that correct? That's a gift from me to you. Yeah? Good thing you practiced because you're going to need it today. Believe it or not, you're like, oh, let's go. Good thing that I practiced. All right, good. Because look what today looks like. Okay. Anyways, get a Cornell note ready, please. I can solve 3D systems of equations. I can solve 3D systems of equations. You don't need a fair model. We already know what systems are. Once again, I can solve 3D systems of equations. I can solve 3D systems of equations. First of all, remind your neighbor a definition for systems of equations without looking at your notes. Definition for systems of equations. What are systems of equations? All right, good. So, before I get to that portion, really quick, systems of equations, you've solved them by graphing in the past. We've graphed them, right? In the previous benchmark, before the end of December, there was a problem where you had to graph the equation, and then you found out the solution was where the equations intersected. We've done substitution on the warm-ups, and then we've been focusing on which one? Elimination. Is that correct? All right. Now, quadratic equations have different ways of solving them. By completing the square. Have we been hammering that one a lot? Yes. By using the quadratic formula, and that was on the benchmark that we just finished, right? By the way, I already have those corrected. I'll give you those tomorrow. Also, square roots, which is the easiest form of solving quadratic equations. By graphing, we already know how to graph quadratic equations using a table and find out where they intersect the x-axis. And the last one, do we know how to factor quadratic equations? Yes, we know how to do all that. We're going to need that for today. So once again, systems of equations, what were they? The set of two or more equations that have the same variable. And you took notes of this the other day that I left you the session, yes? The review session. Okay. And this is what they look like. Two or more equations that make up a system. And that's why today we arrive to 3D. So here we go. 2 dimensions we've been graphing using x and y. Is that correct? Now let me introduce you to the third dimension. Look up. Here it goes. The third dimension is as easy as this. We take the 2 dimension, we tilt it backwards like so, and then we introduce one more dimension coming down like this. You're like, oh snap, yes, that's what we're going to be focusing on. That's where you did a lot of practice already, right? So I'm going to start with this one. This one's my x. This one's y. This one is new, and this is our z. Now, don't copy this. I'm just showing you how we're going to be tackling this. Our solutions for 3 dimensions are still in a parentheses, and it has 3 variables. It has an x, it has a y, and it has a z. So, if I was to ask you to graph a point at 3 of x, negative 2 of y, and 4 of z, you should be able to do that using this. Now let me show you. I'm going to start with 3 of x. 1, 2, 3. So far so good, yeah? Y negative 2. Where's y negative 2? Y negative 2 is 1, 2. So far my point is about right here. Is that correct? But I'm not done, because now I have the third dimension, which is z equals 4. So that means I need to bring it off the table and elevate it to 1, 2, 3, 4. So this point is going to be way up here by bringing it off the 2 dimensions. Everybody see it? Yes? Kind of, sort of? All right, good. Good intro. So, with that said, copy this one, please. Example number 1. Put away those Chromebooks, please. Thank you. We are given the system, and it says solve the system by elimination and substitution. And we are given x plus 2y plus z equals 8, 2x plus y minus z equals 4, and x plus y plus 3z equals 7. If you have highlighters, get those out. You're going to need at least 2 or 3. If you have colored pens, get at least 2 or 3 out as well. Pencils. All right. All right, here we go. So, we are now given a system in 3 equations with 3 different variables. which means at the end I need to come up with a solution with three different numbers. Is that correct? The first one corresponds to x, the second one to y, and the third one to z. In order to do that, we need to break this one down and make it smaller, because it's a little bit too much to ask for you guys to solve it using all the three different variables. Because, why, Mr. Q? Well, because I gave you plenty of practice in systems with two variables and two equations. Is that correct? Yes, Mr. Q. Which means today the first task, is to make sure that each equation is in standard form. What does that mean? All variables to one side of the equation. Are they on one side? Yes. Are they in alphabetical order? Yes. X, Y, and Z, X, Y, and Z, X, Y, and Z. Okay. Next, step 2. We need to eliminate one of the variables from the get-go. Let's see. Let's look at the X's. If we were to combine, can we eliminate anything here? No. How about here for the Y's? No. How about for the Z's? Can we eliminate anything? Yeah, we can actually eliminate these two, but we would leave this one solo, which means we can't eliminate it completely, but we can try. Look up. Look up, please. So if I was to start and I said, I want to eliminate Z. But in this case, you're like, Mr. Q, can I just eliminate these two right here and leave this one for later? Yes, but then how are we going to eliminate if we're done with these and just left with one positive 3Z? Unless I change this one and this one to what? Negative 3 and this one to what? Positive 3, is that correct? So then I need to combine two at a time to eliminate. I'm going to be combining two at a time to eliminate the Z's. But in order to do that, one of them has to be a negative, the other ones have to be positives. So here we go. So I'm going to use three different colors so I can distinguish which ones I'm working with. The middle one, I'm going to label that one in pink, if you have pink, or underline it in red, that's fine. The top one, I'm going to use green. And the bottom one, I'm going to use like a light blue. There it is. All right, let me zoom in. So, I said we're going to eliminate the Z's, but in order to eliminate the Z's, I need one to be a negative. So in order to eliminate this 3Z down here, this one has to be negative 3. Is that correct? And in order to eliminate this one over here, if this one's already negative 3, that means this one has to be 3. So I'm going to change this one first by multiplying times 3. All right? So let me zoom out. Now that you saw what we're working with, here we go. So I'm going to do that in red. So 3 times 2x, that's 6x. 3 times y, that's 3y. And 3 times negative z is negative 3z equals 3 times 4 is 12. And then I want you to write it one more time to the right. 6x plus 3y minus 3z equals 12. So that means I wrote this one twice here. So I'm going to bring the blue one and I'm going to write it underneath the first transformation here. So let's write this one right here. So we got x plus y plus 3z equals 7. Now check this out. This one, don't do it yet, but look. Can I just eliminate the z's already here? Yeah, right? So that means that I need this second equation on top. Look up. This equation is going to go over here. So let me put a highlighter over here of green. needs to go here, but the z has to be a what in order to eliminate that negative 3z? A positive, right? So we need to multiply times 3 as well. So here we go. I'm going to write that in green. 3 times x is 3x. 3 times 2y is 6y. 3 times z is 3z. And 3 times 8, that's 24. All right. So now that we said we used this one twice, I'm going to put a little asterisk so that I can remember the step. So I'm going to use this one twice, one for the blue one and one for the green one. There it is. All right. So let's combine this one. This cancels. That leaves us with 7x plus 4y equals 19. Can we simplify any more? No. Let's go to this one. And, oh, by the way, put a little, a big plus sign so that we know that we combine at that point. All right? The z's cancel. So we're left with 9x plus 9y equals 24 plus 12, that's 36. How we doing? Good? All right. So, what do you guys notice? That we made this big system into two smaller equations. So watch. I'm going to take these two equations and make it into a smaller system. 7x plus 4y equals 19, and 9x plus 9y equals 36. So, let me zoom in. So I am here now. Does this look a little bit more familiar? Yes, right? All right. So now, in order to eliminate either x or y, we said they need to be opposite numbers. Is that correct? So look at the x's. Can we eliminate the x's? No. Can we eliminate the y's? No. So at this point, you choose which one do you want to eliminate. You want to eliminate the x, or do you want to eliminate the y? Let's see. Let's go with Enrique. Which one do you want to eliminate, x or y? He said y. Okay. Question. Can we multiply the 4 to make it a 9? Can we multiply a 9 to make it a 4? So at this point, we multiply both numbers, and the magic number would be what? The magic number would be what? 36, yes? So therefore, we need to multiply the top equation times 9 and the bottom equation times 4. All right, here we go. That gives us 63x plus 36y equals 9 times 9 is 81. 9 and 8, that's 171. 36x plus 36, oh my goodness, 36y, hold on, equals 4 times 36, that's 24, we got 2, 12, 144. You're like, but I still can't eliminate. What should I do, guys? What can I eliminate? We can? No, they're both positive. What shall we do? Multiply by -4. So this one times negative, so this is turning negative, negative, and negative. Very good. All right, Jesus. All right, so now we can eliminate. These cancel. That leaves us with 63 minus 36. That gives me 27x equals 171 minus 144, 27. And then we solve for x. Divide by 27, divide by 27, x equals 1. Next, we need a y value, don't we? So, which equation do you want to use, the top one or the bottom one? Which one? Bottom? Okay. So negative 36 parentheses, negative 36y, negative 144, and instead of x, we're going to substitute 1. Negative 36 minus 36y equals negative 144, and then we solve for y. Plus 36 plus 36, negative 36y equals, let's see, 144 negative and 36 positive, that gives me negative what? 108. And last but not least, divide by negative 36, divide by negative 36, y equals three. Well, y equals 3. All right, let me zoom out, see where we're at. So, at the top, I want you to write 1 for x, 3 for y. What are we missing? The z. So then we go to the original equations and tell your neighbor, which equation do you want to use to substitute x and y to find our z? Which one do you want to use? The top, the middle, or the bottom? Bottom one? Okay, somebody said bottom, so let's use this one. We got x plus y plus 3z equals 7. But we already have x and y, so let me put x and y. X was 1. Y was 3. Then we have 3z equals 7. So this is 4 plus 3z equals 7. And we solve. Minus 4 minus 4. 3z equals 3. Divide by 3. Z equals 1. Solution. So, this is called by elimination and substitution. Why elimination? Because we needed to eliminate one variable to get started. Then from there, we made it into a smaller system. We solved that system. Then at the end, we started substituting those values into one of the equations. Got the other one, substitute those two values into one of the original equations, and got our third variable. All right? All right, copy this next one, please. Example 1Q. Let's go, Enrique. And right on time for Friday. Tomorrow's Friday. All right, example 1Q. Same thing. Solve the system by elimination substitution. We got negative 2x plus y plus 3z equals 20. Negative 3x plus 2y plus z equals 21. And 3x minus 2y plus 3z minus equals negative 9. Copy that. All right, let's do this one together again. Here we go. Before I label my equations, look up. Let's do a quick scan. Can we eliminate x's? No. 2 of them, yes, but not all 3 of them. How about the y's? Two of them, yes. Not the third one. How about z's? No, because they're all positives. So, look up. If I was to combine here for the x's, I can eliminate the negative 3x and the positive 3x. Is that correct? But this one is a 2. I can't eliminate that unless that one becomes a 3. Can we make the 2 into a 3? No. So that would be, I would have to convert all three of these into a 6. So no. However, look at the y's. This is negative 2y cancels the 2y. Is that correct? Could this negative 2y cancel this y up here unless it's a what? A 2, right? All right, so that means this is going to be the one that we use as our red one that we're going to write twice. This one we're going to write twice. So let's write it here and here. That one we don't need to transform, just write it twice. We got 3x minus 2y plus 3z equals negative 9. Let's write it again. 3x minus 2y plus 3z equals negative 9. All right. So then we have, this one's our green one. The other one's our blue one. Now the blue one, since it already has a positive 2y, we don't need to change that. I'm going to write it over here. So let's just write it as is, negative 3x plus 2y plus z equals 21. However, the green one that goes here, we do need to transform because the y has to be a 2. So we're going to multiply this entire equation times 2. So 2 times that is negative 4x. 2 times y is positive 2y. 2 times 3z is 6z. And 2 times 20, that's 40. All right? So let's combine the first set. What is 3x minus 4x, everyone? Negative 1x. The y's cancel. Plus 3z plus 6z is 9z. 40 minus 9, that's 31. Next one, combine the second set. 3x minus 3x, those cancel. 2y minus 2y cancel. Oh, okay. 3z plus z, that's what? 4z equals 21 minus 9, that is 12. Now, look at it. What do you guys notice? Isn't this one missing a variable? Because it already eliminated here, right? Now, check this out. Can we continue in solving for z on this one? Yes? All right. What is z, guys? Yeah, divide by 4, z equals 3. All right, we got z. What do I need to do to that one, guys? How do I find another variable from z? What do I do now for this? Yeah, so we write negative x plus 9 parentheses equals 31. And we're going to substitute the value of 3. So negative x plus 27 equals 31. Let's solve. Minus 27 minus 27. Negative x equals 4. Divide by negative 1. X equals negative 4. All right? So we have an x, we have a z. What are we missing? Yeah, tell your neighbor what to do for us to find that last value. What do? Tell your neighbor. Talk to your neighbor. All right, looks like Mariah's got this one. Mariah, what do we do at the end? Choose any equation from the beginning. Which one do you want to use? The green, the blue, or the pink? The last one, okay. So then right here, I'm going to substitute for x, bring down the 2y. I'm going to substitute for z. All right, so x was -4, and z was 3. So now we have, let's see, this is -12 minus 2y plus 9 equals to -9. Combine like terms, that is -3 plus 2y, minus 2y, sorry. Minus 2y equals -9, and we solve. Plus 3 plus 3. -2y equals -6. Divide by -2. Y equals 3. And this is my solution. All right, from 1 to 5, how comfortable are you with this so far? See, from 4s, 5s, okay, 3s, okay. All right, so before we move on, talk to your neighbor, let them know why did we use this bottom one twice for the other two. Why did we use this bottom one twice for the other two? Talk to your neighbor so like that they know the setup before we move on. All right, looks like Ulisa's got this. Very good, Ulisa. Enrique's got it. I see you, Enrique. All right, so look at this one. Don't copy it. Tell your neighbor which variable would be the easiest to eliminate from the beginning. Which one would be the easiest to eliminate? All right. Elijah, which one? The x. All right. Hands if you agree with that. Yes, but one of them has to be what? Negative. So you pick which one. It doesn't matter which one. And you multiply times -1. So I'm going to pick the last one. And then that one we write how many times? Twice. And then the other ones, you write one of them with the other, and the other one with the other, and then you begin your process of elimination and such. All right, we'll stop right there, guys. Once again, your home plate is on the screen, and you have the code. Those of you following on YouTube, make sure you get some practice in and see how you deal with that. And I'll see you guys next time. Peace.